Okay, we are on page 50, and we are going to prove here that we learned about both rational numbers and Venn diagrams. And notice we have a Venn diagram similar to what we had from page 49, where the innermost circle is only going to be the whole numbers. The next circle out will include integers, and the last circle will include the rational numbers. Let's read the directions real quick. Your turn. Place each number in the Venn diagram, then classify each number by indicating in which set or sets it belongs. Number 9 is 14.1. Is 14.1 a whole number? Nope. Is it an integer? It is not. Integers have to be positive or negative whole numbers. It is a rational number only, so I'm going to put 14.1 right here. And on the line, we're supposed to write the set it belongs to. It belongs to the set of rational numbers. All right, number 10, 7 and 1/5. I always start, the way I do this, I always start in the center. Is 7 and 1/5 a whole number? It is not. Is it an integer? It is not. 7 and 1/5 is simply a rational number. And the only set it belongs to is rational numbers. Now these next couple, it's easy to place them in the right set, but it's a little bit confusing about what you write. So let me help you out. -8, is -8 a whole number? It is not. Is -8 an integer? It is. So I'm going to put it right here. And what a lot of kids really want to do is they want to write integers on this line. And you're allowed to do that. But I want to teach you something real quick. Up in the directions right here, when it says then classify each number by indicating in which set or sets it belongs, it means that there's multiple answers. 8 belongs inside this circle right here, but it also is inside this circle right here, which means -8 is a rational number. -8 is a rational number because it can be written as -8 over 1. So it's an integer and it's a rational number. So we have to write that. If you didn't write both sets it belongs, you need to do that. Last, 101 is a whole number. Since it is a whole number, it is also an integer, and since it's an integer, it is also a rational number. So really we should write all three sets. We should write whole numbers, integers, and rational numbers. If you wrote all three sets, that would be fine. All right, very good. Let us move on. Guided practice. Sarah and 4 friends are decorating picture frames with ribbon. They have 4 rolls of ribbon to share evenly. First of all, how many people is that? Sarah and 4 friends. Sarah plus 4 friends. How many people is that? That is 5 people. It's really important to notice that that's 5 friends. Sarah plus her 4 friends, that's 5 people. Okay, so there's 5 people sharing 4 rolls of ribbon. A says, how does this situation represent division? Think back to when we did the blocks of clay. We had 3 blocks of clay divided by 4 people. This is the same thing. This is going to be 4 rolls of ribbon. And what's happening with those rolls of ribbon? They're being divided by 5 people. Do you remember what we do with this? Question B says, how much ribbon does each person receive? Do you remember before that when we had, this is kind of a note right here, when we had 4 divided by 5, do you remember before that the dividend becomes the numerator and the divisor becomes the denominator? What's the answer? It is 4/5. And it's not just a fraction, it's 4/5 of a roll of ribbon. So I'll just say of a roll. 4/5 of a roll. Now this right here is just notes. This is not your answer. But it is important to understand that. Okay. All right, moving on. Questions 2 through 4. The directions read, write each rational number in the form of a over b. That's the same thing as a fraction, where a and b are integers. Can you write 0.7 as a fraction? If you can say it right, you can write it. 0.7 is the same as 7/10. 7/10 gets written as 7/10. Number 3, -29. Any whole number or any integer can be written as a fraction over 1. And number 4, this is the one where we do 8 times 3 is 24. Add the 1 is 25. 25/3. Okay, I will go ahead and move the screen up. Numbers 5 and 6. It says place each number in the Venn diagram, then classify each number by indicating in which set or sets each number belongs. Number 5 is negative 15. Since it's a negative, it belongs in the integers. So negative 15 belongs in the integer set, but since it's an integer, the integers circle is also inside the rational number circle, so integers and rational numbers. And 5 and 10 11ths, that's not a whole number, that's not an integer, that's a rational number. 5 and 10 11ths goes here. And that is in the set of rational numbers only. Number 7, how is a rational number that is not an integer different from a rational number that is an integer? So a rational number that is not an integer would be something that would go in like this circle right here. And a rational number that is not an integer would be something like in fact, I think I'll type. A rational number that is not an integer has to be a fraction or decimal. A rational number that is an integer would be something like -7 or -99. Or actually, we should choose our example we had from this number 7 right here. It's interesting. This number 7 right here is summarizing numbers 5 and 6. The first part of this question, how is a rational number that is not an integer? That's number 6, 5 and 10 11, or I'm sorry, yeah, 5 and 10 11ths. A rational number that is an integer is like negative 15. So number 7 summarizes 5 and 6. These two things are the examples. This right here, this is a rational number that's not an integer. And this right here is a rational number that is an integer. Now, why are they both rational numbers? Well, rational numbers are anything that can be written as a fraction. Negative 15 can be written as a fraction as over 1. Okay, good job. You're done with page 50.